Good morning and hi everyone. I am Dr. Mudassir Ali Khan, PhD in Civil Engineering from University Technology Petronas, Malaysia, with a specialization of Geotechnical Engineering. And my research interest is debris flow interaction with infrastructures. I have 4+ year of experience in teaching and research, published 15 index article in reputed SCI Scopus journal. Currently working on a landslide impact modeling in Himalayan region in collaboration with CSIR CBRI Roorkee. Before that, I have served as an assistant professor in civil engineering in Integral University, Lucknow. And I also have the graduate engineer certificate from BEM Malaysia, which is one of the important certificate to practice as an engineer in Malaysia, and also to apply the teaching positions. So today I am here to deliver on a lecture topic the foundation engineering and design principle. So foundation engineering, one of the important subject of civil engineering, and it's related to the design of different type of foundation to support the structure. So why the foundation engineering important? Like a foundation engineering is the branch of engineering in which the foundation is designed on using the application of mechanics and soil mechanics and rock mechanics in the design of foundation. And now question arise: what is foundation? Foundation is the part of a structure, more commonly known as a base, and is the element which transfer the load of the superstructures to the ground safely. And this is the typical example of the foundation that we normally construct. So why to study the foundation engineering? Foundation engineering is an important subject. I already told that 15% of structure failure originates from the ground. If we don't understand the ground behavior or soil behavior in different conditions, then our structure have always be on risk. And poor foundation lead to tilting, settlement, or even collapse. So the foundation engineering is also essential for infrastructure in varied environment like coastal, marine, or mountainous region, especially the seismic zones. And more common cause of foundation is the increase of moisture and its interaction with the soil beneath the foundation. It led to the shrink and swell of the soil, which led to the crack and differential settlement, normally on the floor slab or maybe the joints of the column and slab. So so we need to carefully observe these factors, and this is the typical example of the foundation failure. You can see in these images the whole structure is first start tilting and ultimately fail or collapse. You can also observe that no structural element has been like broke or damaged, directly collapse. So it is the totally complete failure of the foundation. So objective of this course is to provide the basic concept to the student regarding the fundamental principles that are necessary to understand for the safe and reliable foundation design. To aware the student on the significance and limitation of the popular methodology that used to design the foundation, and to provide the student a framework for a student to carry out a simple foundation design and appreciate the design process. So now coming on the types of foundation. Foundation are broadly classified on the different basis on the purpose of studies, but broadly classified as the shallow and deep foundation based on the dimension of a foundation. Shallow foundation is normally that when the then the width of the foundation is greater than depth of the footing, then it is known as shallow foundation. It is relatively laid on a shallow depth, and this is a typical example of the shallow footing or shallow foundation. And deep foundation is vice versa, that depth of footing is too much greater than the width of the footing, and it is typically classified as well foundation, pile foundation. And shallow foundation is classified as the spread footing, combined footing, mat foundation, stiff footing. And the deep foundation, typical example of deep foundation, you can see here the micropiles that is resisting the tower or structures. Okay, so now onward we are discussing about the shallow foundation. So this particular lecture is to understand the shallow foundation, its behavior and design consideration. So okay, so spread footing is the type of shallow foundation in which we have different type of spread footing like pad, step and slope footing. These are footings normally constructed on isolated column, or we can say the single column, and it might be in different shape like square, rectangular or circular shape, and is designed on the base of load and soil bearing capacity. Especially if we have a variable bearing capacity, we go for the step footing. If we want to have some economical requirements, so we try to go for slope footing. And similarly, if we have the no issue of that concrete saving, then we go for the pad footing. Now we another is combined footing. Combined footing normally construct where we have the two column are closely spaced, and when there is a near a property line, and we have to prevent the symmetrical footing. These are the typical, this is the typical example of the combined footing. You can see here that the base of the footing is the connected to a reinforcement, and it's act as a single footing. Now another footing is the mat foundation. Mat foundation is normally constructed the place where the large or heavy loaded are transferred to the smaller areas, and the columns are very closely spaced, and we have to transfer the huge or heavy load to the ground. So it is similar to like a slab connecting the column. Just the reverse case, the slab is normally up and the column is down. In this case, the slab is down, and then we have the column connected to this. So basically this is for the to transfer the heavy load to the ground in a smaller area. Then we have another type of spread footing, or that is a strip footing or continuous footing. uh, so this is the footing normally provided to support two or more closely spaced column, or to support the masonry bearing wall, load bearing wall in masonry structures. This is the typical example of the strip footing. Now, how to choose the foundation? This question arises that which type of sound foundation is suitable in our case, like what we are dealing the current scenarios or the site conditions. So for that we have to consider these factors, that these the important factor: soil bearing capacity and type, settlement and different settlement, ground depth fluctuation, load, environmental scenarios, and also the nature of superstructures, how which type of superstructure we are going to construct. For that, it is directly related to the soil exploration, or we can say that the foundation engineer must have the prerequisite knowledge of the soil, and how it will be happen. Then to for that we need to go, or we need to understand the soil mechanics. And these are the basic tests that going to be uh, normally happen in the site while we construct any foundation: borehole log, standard penetration test, groundwater table, plate load toss, or then after that soil classification. It depends upon the foundation that we want to construct, so we will go for that these type of tests. Then design consideration. To design the shallow foundation, we have there are two consideration that we must satisfy. First is that shear failure criteria or bearing capacity criteria, and the second one is settlement criteria. The foundation should be designed such that the soil below does not fail in shear and settlement. For that, we have to calculate the bearing capacity and also the settlement. So this is the typical example of the loading scenario that might occur on the foundation, that we have the QG, the gross load, which is the summation of the concrete, or we can say the superstructure load, then weight of fitting, and the weight of surcharge that's coming by the backfill. And from there we can calculate the gross pressure intensity. Using this, we can calculate the bearing capacity. Before going to the in detail, we must understand the basic terminology that used in bearing capacity calculation. First is that ultimate bearing capacity. The ultimate bearing capacity is nothing but the maximum gross intensity of a loading that soil can transfer before failing shear. Yeah, we our aim is to design the foundation that it does not fail in shear. So that is the ultimate bearing capacity of the net ultimate bearing capacity. The maximum net intensity of loading at base of foundation that soil can transport or support before fail in shear. This is the typical formula of that, and you can see that net shear bearing capacity, and this is the maximum net intensity of loading that soil can safely support without risk of shear failure. Normally, we just take the factor of safety to avoid the complexities of the soil that we are studying. Sorry. Then shear failure criteria, we have the gross shear bearing capacity. Another term, the maximum gross intensity of a loading that soil can carry safely without failing in a shear. And this is the typical formula of the gross shear bearing capacity. Now the second one is settlement criteria. So we have the maximum net intensity loading that can be allowed on a soil without the exceeding the settlement permissible value. So we have to calculate the bearing pressure that it does not exceed the allowable settlement in a soil. That is, in every country we have the codes which provide that this type of soil or this type of foundation is allowed to settle only this much of amount of deflection or settlement. So so our foundation must be designed which satisfy these two criteria, that is settlement criteria and the bearing capacity criteria. Then so we have the modes of failure, soil failure, and it is totally defined by the type of soil that we are dealing with. Normally we found the general shear failure, local shear failure, and punching shear failure. These failure is depend upon the type of soil that we are dealing with, and how we can classify the type of soil using the unconfined compression stress and the consistency in case of clay, and relative density and consistency in case of sand. So general shear failure normally occur in dense sand and stiff clays, in which we observe the well-defined failure surface and bulging of the ground surface, and ultimate load are easily be calculated. And then we have the another modes of failure, that local shear failure, which normally occur in medium or relatively loose sand or medium to relatively soft clay. It is slightly different, that well-defined wedge and slab surface only found in the only beneath of the foundation. Slight bulging and ultimate load cannot be easily located, and significant compression of soil is observed significantly just beneath of the foundation. Then punching shear failure is similarly like that. So moving on the Terzaghi's theory, like bearing capacity theories, there are lots of theories developed so far to calculate the bearing capacity, in which we have the Terzaghi's, Meyerhof, Hansen theory, and basic theory. So the first and most of the theory, it's based on the Terzaghi's theory, and Terzaghi was the first to propose the comprehensive theory for evaluating the safe bearing capacity of shallow foundation with rough base. So obviously the soil is very complex. So to design the foundation, or we to draw some conclusion, the Terzaghi proposed some assumption that soil should be homogeneous and isotropic. Shear strength of soil is represented by Moore Coulomb criteria, and the foundation is stiff footing type with a rough face, and method supervision is valid, and effect of water table was neglected. And after that, he proposed the slip surface, or we can say the typical envelope of the shear failure for the stiff footing. So he proposed the bearing capacity equation to calculate the ultimate bearing capacity of a stiff footing, which is the CNC plus gamma DF NQ plus half gamma BNR. C is the unconfined compressive strength, or we can say that the shear strength, or NC is the NC, NQ, and gamma is the bearing capacity factor, and gamma is the unit weight of a soil, which comprising the depth of foundation, and another gamma is the unit weight of a soil, which comprise the width of the footing. And these are the bearing capacity, the typical values of bearing capacity and different angle of internal flexion. And also he proposed the chart for that. So from here we can calculate the bearing capacity factors to calculate the bearing capacity of stiff footing. And also because he assumes lots of things, so there is a limitation of that uh, theory. But it's the base of all the theories that we have learning and using nowadays. So it's a typical solved example you can see here to calculate the safe bearing capacity of stiff footing. And these are the details, like we have the general shear failure and water table is at grad tape, and these are the uh, given parameter of soil and the dimension of a footing. So it's a very easy, and you can just calculate the bearing capacity using that simple formula that was proposed by the Terzagis. And from here we can calculate the ultimate bearing capacity, which is come out 597.2, and here we have the 579.2, that net ultimate bearing capacity using the those same formula that we discussed before. Factor affecting the bearing capacity calculation. So we know that soil is very typical or complex to understand, and different parameters also influence the bearing capacities, like type of soil, stratification, surcharge load, depth of foundation, mode of failure, and size of footing. So these if we consider these all the factors, we can have a more reliable value of uh, bearing capacity. And other researchers or scientists consider these factors, which will be discussed in other classes. And the key takeaways from this class is, we can just summarize what we have learned, is that foundation is a critical part of structure. Soil shows complex behavior in different loading and saturation condition. Foundation broadly classified as shallow and deep. Bearing capacity depends on numerous factors, and Terzagi's theory gives the bearing capacity of stiff footing. In upcoming classes, we will going to discuss about the different factors that affect the bearing capacity, especially the water table, shape, stratification, eccentricity, seismic effect, and also the other theories that are improve the bearing capacity calculation, especially Meyerhof and Hansen's theory. And after that, we will going to discuss about the deep foundation, like well foundation, pile foundation, and other type of foundation. Thank you very much for your patience and listening, and see you in the next class.